Hello, my name is Joel. Here I'm here to talk about power developed in transistors, NPN transistor, and the fixed bias also. Now let's take this. Now if you look at it, N P N from your normal symbol N P N. Check. So the base is positive in respect to the collector. The base is positive in respect to the collector, and the base is positive in respect to the emitter. So we look now the fixed bias. I'm using this instead of this. So we add the base resistor and the load ROC. Now if you look at this, current will flow through from the positive to RC and to emitter, and the current will flow also from the to the base. The two currents meet up at the base pin to sum up to give us this. Since they are both positive, we have IE is equal to IC plus IB. Pardon me, I've already calculated it down. So like the work is, so this will sum up to give us IE. Now IB, if we assume we don't know this, now IB, I didn't want to derive IB directly, since the two currents sum up to give us IE minus IC will give us IB. IE minus IC is equal to IB. Now from the power formula, P is equal to IV or I square R. Now to use this, that means we need to replace this voltage source with the equivalent resistance, and this also with the equivalent resistance, and then these two will sum up, then in parallel with this, then in series with this to give us R. And I here is when you remove the positive supply, then you place your current meter to give you I, then you square the value and the total resistance you got from this circuit. So instead we use this, P is equal to IV. Now we know current will flow through here is the same, but when it get to this point, it added up to give us IE. So since current is flowing through this, let me use this, current is flowing here, so power is developed across this voltage source. So IC times VBC, C and B, that is VBC, plus, now the two currents sum up to give us IE, V, B and E times VBE, sum up the two power, it will give you the total power in the transistor. In my earlier video where I left one pin floating, you can also see from there also. So now to get the voltage across one of the pin, now we take Vs from this is the positive and this is the negative, we are decreasing in potential, Vs minus Vc, and from here the collector to the base we are increasing in potential. If you look at it here, from collector to the base we are increasing in potential, and from the base to the ground or the emitter we are decreasing in potential. So you can see everything will give you 0. Now let's ignore the fact of 0. Remember VBC minus VBE, VBE minus VBC will give us VCE, since emitter pin is directly grounded, so it will give you your VCE. So replace this with this to make it more simpler. Vx minus Vc is equal to VCE, and VB, now Vx, if you look at here now, Vs we are decreasing in potential minus VB, Here also we are decreasing the potential. Everything will sum up to give us 0. So but I've done, so what I have done is this: VB, we are looking for VB, the voltage across the resistor, is equals to Vx minus VBE. If you look at it to complete the part, so VBE. Now in the case whereby we have 12 volts that is being supplied and the current here is 10 milliamp, HF is 100, VB is 0.7 and VBC is 0.5, IE is unknown, RB is unknown, RC is unknown, we don't know the value. Now IB is equal to IC over HFE, there is current magnification or beta. In some cases you will see beta, so beta 10 milliamp divided by 100 is 0.1 milliamp. That means 0.1 milliamp is the current flowing to the base. So directly IE is now found. Since remember we have IE is equal to IC plus IB. So if we sum up 0.1 milliamp plus 10 milliamp, it's not done here. So IE is equal to 10 milliamp plus 0.1. We have IE to be 10.1 milliamp in total. So now to find VB is Vx, remember, Vs minus VBE 0.7, we have it to be 11.3. Using your normal Ohm's law, V is equal to IR, and to make R the subject of the formula, V over I will give us R. So we have the voltage 11.3 divided by 0.1 milliamp give us 130 kilo ohms. So and VC minus is equals to Vs minus VCE. So 12 volts minus, remember I said VBC minus VBE, sorry, VBE minus VBC will give us VCE. So 12 volts minus 0.7 minus 0.5 will give us VC is equal to 11.8 volts. Now 11.8 volts divided by the current flowing through IC give us 1.8 kilo ohms. So the value of 4.18 kilo ohms, pardon, 1.80 kilo ohms is the resistor. Now remember, to get the power developed in the transistor, PT is equal to IC times VBC plus IE times VBE. IC is 10 milliamp, VBC is 0.5 plus IE is 10.1 milliamp times VB is 0.7. Sorry, okay, 0.7, 10 milliamp and 0.7. So PT is equal to, hold on, 0.5 times that means we have 5 milliwatt plus 10 point, remember 10 milliamp times 0.5 volts and 10.1 10.1 times 0.7, so we have 7.07 milliwatt. Total power developed across the transistor is 12.07 milliwatt. or power that is being developed. Now in the case where you see P is equals to IC times VCE, so let's calculate for that also. You see that this one is not right, so PT is equals to IC. Remember, IC is 10 milliamp and VCE is 0.2 volts. Remember, yeah, 0.7 minus 0.5, which gave us our VBE minus VBC. Remember, give us this, so 0.2. So milliamp times 0.2 give us PT is equal to 2 milliwatt. You see, compare 2 milliwatt in this. Now note, remember, if you minus this from the and this from this, you have the VCE. So you see, so to know the power developed across the transistor itself, you must know this and this. Then you sum it up. That is the total power developed across the transistor. Thank you. My name is Joel.